So we are learning about piecewise functions today. Now, I believe that you did at the end of Algebra 1, I know it was so long ago for you guys, but at the end of Algebra 1, you did intro into piecewise just a little bit. A piecewise function is exactly like it sounds. It is a bunch of pieces of graphs put together. It's like multiple different functions all on one graph. A piecewise is defined as a function whose domain is divided into several parts. This is two or more, right? Because one part, it wouldn't be a piecewise anymore. It would just be a function. Oh, look at Kitty. Sorry. A different function rule is applied to each part. This basically means each part has its own function equation. Then each part has its own rule within a restricted domain, which we talked about restricted domains a little bit in Algebra 2 as well. So we're going to go ahead and graph it. See a blank graph here, and then right next to the blank graph is our very first piecewise function. Now, normally piecewise functions are the function is equal to, and then normally it has like a big bracket that is the entire length of your two functions. Normally it's not a bracket and then it ends with the bracket. This person, whoever created these notes, didn't understand how to put in the big bracket, I think. Now notice here, there are two separate functions. There are two separate equations written. Our first is negative x if the x values are less than 0. And the second one is x if our x values are bigger than or equal to 0. So this means we are right now going to be graphing two separate lines, depending on which x values we're talking about. So let's graph the first one. It has our slope as being -1, and it doesn't have a b value, meaning the y-intercept is 0. So if this line is -x, does anyone know what that's going to look like on our graph? Is it going to be starting in the top left or the top right? Yes, good, good, good. Because a negative slope goes up 1 and then in the negative direction 1. Up 1, negative direction. And it's a -1, so I'm just going up 1 over 1 every time. And then this is the part of the function that is -x. Do you need to label each part of the function like I did on the graph? No, I'm just doing that so that you can see which part we're graphing. Does anyone know what I did wrong here? Yes, yes, exactly. Look, -x is only referring to the x values that are less than 0, not less than or equal to. So technically, this part of our function, whoops, is not touching 0. It gets an open dot. Don't worry about crossing it off or erasing it if you wrote in pen, because we're going to fix it in a second. Then our next line is just x. Our slope is 1 over 1. It doesn't have a b value, meaning our y-intercept is 0. Now this is including 0. So I do put a closed dot on 0, 0. Up 1 over, oh, I should do a different color. Be sure to stop me if I'm confusing you. But I should hope that at this point in your math career, you're kind of okay at graphing. Are there any questions on how this graph turned out? What parent function does this piecewise function form, I think that says? Yes, form. Yes, absolute value. Does this function contain the origin? Why or why not?
I think it does because the second line
Exactly.
is closed up.
Yes, yes, exactly. The second line includes the origin because it's for all x values greater than or equal to 0. Yes, because it's a closed dot. Very good. What did I write? Yes, because the line or function f of x equals x has a domain of x is greater than or equal to 0. You can write that in your own words if you want. There's a closed dot, whatever. As long as you understand that, yes, the origin is included here. Is this graph continuous or discontinuous? Yes, it's continuous. Does someone want to tell me in their own words why this graph is continuous? What do they do to prove it's continuous? Yeah. Yeah, there's arrows on each end. Okay. Because it continues to go onward, yes. All right, I guess I'll explain how I do it. I was looking for someone to say this. I don't know how you were taught continuous versus discontinuous, but how I think about it is if you're looking at a graph and you're tracing from left to right, right? You're tracing along the graph. If you ever have to pick up your pen to move to a different portion of the line to then continue onward, if you pick up your pen, that makes it discontinuous. Yeah, literally, there are no discontinuities. Yeah, which is an open dot on the graph, right? So if you had an open dot on the graph, like this, I would have to pick up my pen. If I'm going from left to right, I would have to pick up my pen to skip over that discontinuity. So this graph is continuous. Someone else in the other class explained it at, whoops, forgot the U. What did I do? Continue. Okay, there's two. Yeah. Someone else in the other class explained it by looking at the domain, actually. The domain helps you. Here, if I had, instead of x being less than 0, it had been x is less than -1. You're missing the values between -1 and 0. So then that would again be discontinuous. All right, moving on. Any questions so far? So the closed dot cancels the open one. Exactly. Yeah, it does. It's like I create an open dot, but then the next graph filled it in. It filled it in for me. So I'm all set. Okay, so now we're going to graph. I am not going to graph all of these right now. I'm going to graph the hardest one. I'll graph this last one. All right. And I'm going to graph it, I am going to graph it as in you were having issues with graphing, which I told my classes last year, if you're ever having issues with graphing, the very first thing you should do is create a table. Plug in x values, get your y values. So that's what I'm going to do. I'm going to graph from top to bottom. Here we have x squared if x is less than or equal to 0, meaning that in my first table, I am only going to put x values that are less than or equal to 0. So I'm going to first try 0. When I put 0 in for x, what does my function equal? Yeah, right? 0 squared is 0. So that's the first point I graph. 0, 0. Notice I put a closed dot because this is less than or equal to 0. So because it's equal to 0, I can put a closed dot on that 0, 0. I'm so sorry. I put y, but really, I should put f of x. I always do that kind of thing. Then I'm going to go down. I'm going to go 1 less than, -1. When x is -1, what's my f of x? Exactly. -1 squared is 1. So I plot the point -1, 1. Then I'm going to do -2. 3 points. 3 points for each graph is good. So I'm going to plug in -2, and what do I get?
4.
Wonderful. And then connect the points. And obviously this is a quadratic. So because I'm not using all of my x values, this should look like half of a quadratic, which it does. Perfect. Then I'm going to graph the second part of my function, the 4. Now notice, is there an x value in this equation? No. So this is going to be a constant function. Now I didn't, in my third period, put a table for this one because in my head I'm like, okay, yeah, it's just 4. But then people are asking for the table, so I'm just really quickly going to put it. When f of x is 4, what's your x value? No, I'm so sorry. When x, so we're going from 0 to 3. So when x is 0, what is your f of x value? Yeah, literally. And then I'll do 1. When x is 1, what is your f of x value?
Wait, x can't be 0.
Right. So that's a good question. X is not 0, but it's everything right up to the 0. So I still want to know what that point is. Because at that point, I would put an open dot. Then when x is 1, f of x is 4, and it continues on all the way up to 3. When x is 3, f of x is 4. So like Jessica was just asking there, but x cannot be 0, I still need to know where that point is, because on that point, I need to put an open dot. So I go from 0 to the x value of 3. Again, neither of those inequalities have an equal to sign below them, so both get an open dot. And that is my constant line right there. So you can already tell, is this graph going to be continuous or discontinuous?
Discontinuous.
Discontinuous, good. And then lastly, our last line. So this was the green one, this was the red one. Now I'll do what, purple? I have x minus 1. So my x minus 1 line goes from 3 upwards, right? X is always greater than or equal to 3. So my first x I'm going to plug in is 3. When x is 3, oh geez, I can't seem to like fix that bad habit of mine. When x is 3, what is your f of x?
2.
Yes, right? 3 minus 1 is 2. And it is equal to 3. I have an equal sign below, so I put a closed dot for that point. So I have 3, 2. Then when x, I'll go up 1. When x is 4, what's f of x?
1, 3. Sorry.
Good, yes. So we have that. And then you can see, okay, yes, this is making sense here. My slope is 1, so I am going up 1 over 1 each time. And that's my line. Again, if you're solid on graphing, do you think you need to write down these tables? Probably not. When I was graphing this on my own, I didn't write a table, but I know for a fact that people were still really fuzzy on graphing last year in Algebra 2. So I did want to show you, okay, what do you do when you're confused how to graph? You draw a table. Any questions on this graph? When does this class end? I'm still not used to this schedule. Okay, good. So now, where am I? Where's this page? Uh-oh. Oh, there we go. So now we're going to go the exact opposite way. We are going to look at a graph and we're going to write down the piecewise function. I'm going to do this one right here. Can anyone tell me how many lines of function am I going to write for this piecewise function?
3.
3. 3 is an option, right? Because I have 1, 2, 3. Anyone see something different? Does anyone see anything different here? What do you see? Like, do you have to do 3 different lines? What else could you do?
Could you do an absolute function?
Yes. Look,
An
isn't
absolute
this like an
value?
absolute value function, but with a restricted domain? Yeah. You could also treat this as a line with the middle portion missing. There's actually 3 different things you could do here. But I'm just going to split it into 3 totally separate equations, which is fine. It's also correct to do it that way. And I'm going to work left to right. So first thing I need to do, and I'm going to label it so that we can keep them straight. I want to figure out what is the equation for part 1. So I need to, these are all linear lines if I'm splitting it into 3 separate parts. They're all linear lines. I need a slope and I need a y-intercept to write down their equations. So what is the slope of that part 1 line? What's my rise over my run?
1.
It's a positive 1, right? I go from one point to another. I rise 1, run 1. So it's a positive 1. Exactly, yes. So I can just write x. And what would, if this continued onward, what would my y-intercept be? So this is the equation of my line, just x. For what x values am I graphing this line, though? And it looks like Andrew did answer this already. I'm only graphing this line when my x values are less than or equal to -2. Notice it's a closed dot there on that -2, so it is less than or equal to -2. Some people just put a big space between the function equation and the restriction. Some people put a oh my god, a parenthesis, a comma. I just do a big space. All right, let's write the equation for part 2. Again, linear line. What's my slope? Yes, this time it's -1. I rise 1 and then go in the negative direction 1. So it's 1 over -1 simplifies down to -1. And what is my y-intercept? 0, so it's just -x. For what x values am I graphing part 2? Yeah, I'd probably do it the other way, Andrew. It's from -2 to 0. And because there's an open dot for that -2, you just put a less than symbol. And there's a closed dot, or it's actually touching that 0, so I can put less than or equal to 0. And then lastly, part 3. So the slope of this line, the rise over the run is 1 over 1. So my slope is 1, so it's just x. And my y-intercept is again 0. So my equation for this last part 3 is just x, which makes sense because remember we said part 1 and part 3 could technically be considered one line. So they should have the exact same equation, which they do. Then we are graphing part 3 for the x values between 0 and there's an arrow. So yes, when x is, now here's the trick. Because this is considered one function, you cannot repeat your x values. So because I included 0 here, I had less than or equal to 0, I cannot have greater than or equal to 0 because then I'm accounting for that 0 twice. Because by function rule, for every one x value, you can only have one y value. So instead, it's just greater than 0. It does not matter which one you give the 0 to. You could have written this. And that is also perfectly correct, as long as only one of them gets the equal to 0. Does that make sense? Are there any questions there? This is so hard for me as a teacher because normally in a classroom, silence, dead silence, means no one gets it. And that's all I hear is dead silence. So it's really hard to gauge, but just going to move on. All right, I'm not going to do this next one because the only tricky part about it is you have to solve for the b value. Just a random scream to cut this, right? So you do have to solve for the b value on one of these equations. I'll be posting the key to these notes. So if you have forgotten how to solve for a b value, you can just look there. Yeah. All right. So now, how much time we have left? 1:55. 10 minutes. Yeah. So I'm going to do example 1, and then I'm going to skip over example 2 because it's a beast. We're not going to ask you to do something like example 2 on the quiz or test. Yeah, again, my key will be posted, so I'll have the answer there if you're curious how to solve it. It's just there's a lot to the problem. And then I'll do example 3. So example 1 says a wireless phone provider charges $25 a month when you use up to 2 gigabytes of data. As soon as you use 2 gigs or more, they charge $10 a month for each additional gig. So part A says find the cost of using 0.5 gigabytes of data. How much would it cost me a month or for 1 month if I only use 0.5 gigs?
$25.
Mm-hmm. Yeah, all the way up to 2 gigs is still just 25 bucks. That's all I owe. Then it says find the cost of using 6 gigs of data.
$65?
Yes, good. I'm just quickly, I know it doesn't ask for it over here, but I'm going to just quickly write the piecewise function that I would have created. Nowhere in this does it ask you to write this. I just want us to get used to using piecewise functions. Why is this glitching out? All right. So yes, it's $65 because You have to add on the additional, or the additional, oh my gosh, the original 25, but then it's $10 for each additional gig, and there's only 2 additional gigs, or 4 additional gigs, so sorry. So 4 times 10 is 40, plus 25, 65. And then it says, what functions, what type of functions do you see in the scenario above? What types of lines are these?
Exponential.
You would think so because it keeps going up and up. But if I'm looking at the only x that I have in these equations, if I'm looking here, is this x being squared? Does it have an exponential x? Yeah. So this initial one is constant, right? It always stays the same. And then this one, this bottom one is what? Linear. Now I know, and I saw one teacher wrote constant comma linear. Isn't a constant line a linear line? I would just write linear. What is going on with my surface? It won't let me write. There we go. Linear. All right. Any questions? I mean, example 1, really, you should have been able to think that one through. I love those type of questions on the SAT, right? Because you can just logic your way through it and not really know math that well. Example 3. Here's where we're really going to have to apply piecewise functions because it asks us to write the piecewise function. It says a house painter charges $12 per hour for the first 40 hours he works, time and a half for the first 10 hours after that, and double time for all hours after that. He will not work over 70 hours in a week. And then it wants us to write the piecewise function. So I'm just going to do a big T and then H for hours. Does it matter what variables you use there? No. No. Okay. Does anyone want to tell me? So we're going to have to write 3 lines here, right? 1 for the first 40 hours, 1 for the 10 after that, and then 1 for all hours after that, less than 70. Who wants to tell me what the equation would be for the first situation?
Would the first line be 12x?
Yes, or 12H, exactly.
Yeah.
$12 per hour is how much we're going to owe this guy. And then we have to restrict our hours for that first equation. What hours apply to 12H?
40. That's less than or equal to 40.
Exactly. Now I would say, because we don't technically want to say just x less than or equal to 40, because technically that means we're going to go into the negatives. Do you think we want to work negative hours or have him work negative hours where he owes us money? No, right? So we have to define from 0 to 40. Now here, I would be impressed. What would the second line of equation be here?
Would it be 18?
It is going to be 18. That's great. So it's great that you can recognize that. When it says time and a half, if you are working time and a half, it means that you're getting paid as much as you would for 1 hour plus half of another hour. So we get $12 an hour. 12 plus 6 is 18. Now, am I just going to write 18H? Now, because think of it this way. If I'm working 45 hours, am I all of a sudden, for all of those hours, going to be paying him $18 an hour? For which hours am I paying him 18?
The first 10 hours after the 40 hours.
Yes. So what you do here is you take away 40 from the number of hours he's worked. So if he worked 45 hours, it would be 45 minus 40. I'm only paying 18 for 5 hours. Is this the whole equation? This is only accounting for those 5 example hours, right? What about the 40 hours he's already worked? What do I do with those 40 hours he's already worked? So what, you're right, plus 12, how many hours would he have already worked? What is the H? We've got 2 minutes, perfect. No, so okay, here we go. We've worked 45 hours, right? So 18 times 45 minus 40, that's 5. So 18 times 5 is how much? I don't know. What's 18 times 5?
90?
Is it really? Okay,
I don't know.
so 90, right? Am I only paying him $90?
No.
No. What else do I have to pay him?
The other 40 hours.
The other 40 hours, which how much per hour was I paying for those 40 hours?
$12.
Ah, so what is 12 times 40?
360.
That one I know no.
480.
480, yes, 480. And for which H values am I applying this second equation? From 40 to, yes. Now the last line is double time. So if he's working double, I'm sorry, if we're paying him double for time after that, how much are we paying him per hour?
$24.
Yes. Now are we paying him 24 for all of the hours he's working? For what hours are we paying him 24?
After the first 50 to 70.
Yes. So I take my number of hours minus 50, right? Say he's working 55 hours. Yes, exactly, after 50. Now, is this all I'm paying him? What do I also have to account for?
All the money before that.
All the money before that, right? So we have to account for that 50 hours, which is, yes, plus 660. And this is the hours between 50 and 70. So notice the pattern here. We always subtract the top. So in the next equation, if I'm looking at this bottom equation, we got the 50, that H minus 50, from the previous top of the previous domain. And then we got the 660 by taking that top number and plugging it into the one right above it. So when you plug in 50 for H, 18 times 50 minus 40 is 10. 18 times 10 is 180. Plus 480 is 660. And then all of these lines, again, are linear. So I really dislike teaching piecewise word problems because there isn't really a way to teach it. I can show you an example, but you kind of just have to think your way through it. I will say that the one on the quiz and the one on the test is very similar to this. Are there any questions?